Yeah. So actually, this is our batch three officially. We starting batch three. So I think Deepthi and Pooja Singh, you are the new enrollee, right?
Yes, sir.
So may I know the background check or background knowledge of both of you? So you have familiar with the Linux, right? Both of
Yes, sir. No, sir. I'm completely from medical background. I had a medical coding experience in India. Now I'm doing AWS Devops course. I had a little bit knowledge in DevOps. That's it.
okay, fine. I'm just checking that I need to add that basics to in our existing syllabus. So both of you familiar with the cloud, right? AWS.
Yes.
Okay. Deepthi, I think you are not familiar, right?
Yes.
I'm also like, I mean, I just need to know like the basics as well, like if it helps, like, I mean, if it is okay with the others.
Okay, fine. So this is our first week, okay? So mm, okay. I need to iter something like I need to include the basics of Linux. So I will add the basics in week one, okay? So that
Okay, sir.
we can
Okay.
start with the DevOps principle benefit challenge. Then we will include the Linux. I mean, we will start Linux from week one. Then we'll continue to week two. Okay. Then even we go through the each lab, we will mostly work on Linux. So don't, I mean, confused about that.
Okay.
Okay, sir.
So both of you, any idea what is DevOps? Why
Developing and operations.
right. Why we choose DevOps engineering? I mean, in our software development life cycle.
I know like some people do developing team and some people do operations side. Once previously they both get some clashes regarding to the internal project that then they combinedly doing developing and operation.
Okay, fine. DevOps engineering. Is this name of any job post or any job? Any idea? DevOps. Actually, DevOps is actually a culture, okay? Culture of practices like how we collaborating with the development side and development side and we will create a bridge, okay? That's a simple scenario. Create a bridge between dev and operation. DevOps DevOps engineering is actually a work culture, okay? That culture have practices and it will sort out the bridge between development and operation. So there's a definition for DevOps. It's DevOps is a set of practices that combine software and IT operations. Practices that combine software developments, that is called Dev, okay, and IT operations. It aims to shorten the system development lifecycle while delivering features, fix, and update frequently in close alignment with the business objective. So there are some key concepts coming to DevOps engineering. The first one is collaboration. Here, breaking down silos between development and operation. That means before DevOps, okay. Before DevOps, these two teams works differently, okay, like isolated way. So this is a dev team. So here there is a lot of developers there, developers. So their job is to coding the applications. Then they will test their application, their own environment, build and test on their environment. Okay, like that laptop. And after the successful test, what will they do? They will push the code or setting the code to operation team. So enter code will here. Okay, now like operation team. So what they will do? They again, I mean the operation teams, the IT person, the IT persons are here, like system administrator, engineers, cloud engineers, all people are here in the operation side. They will mostly work with the operations. Okay, system infrastructure management happen here. Okay, like machines, database, application, all the things managed by operation people. So in this case, they will test the application in their own environment. Okay. For example, here 10 developers there. Okay. There are 10 developers. So these developers using their own machines. I mean, laptop or desktop for creating code and build and test on their environment. Okay. For example, 10 people have 10 laptops. So all the applications run successfully on their own laptops. Okay. So that they will send the code to operation team. So whenever they, hear their code, so the operation people runs the code again on their own infrastructure or machines or laptop, any infrastructure. Okay. So at that time, they will face some error. Okay, when running the application. This process before deploying to production. Okay. Before pushing to production, first the operation people runs the application locally on their own machines. So at that time they will face a lot of errors, like some bug. Main issues is library issues or dependency issues. That's the main problem they are facing. Okay. Before the problem is, for example, here for example, so they will run Python application. Okay. So for developer side, okay, developer perspective, for running a Python application, they must or they should install or adding the dependencies to run the application. Okay. Dependencies, libraries, and all the things. Okay. These related to the version as well. Okay. They have their own versions. So when the code comes here, the problem is the operation people faces so many issues, okay, related to dependencies issues or library issues or any other version issues. So there is some lack of, sometimes happen here, okay, because again, what they will do, they need to inform to the development team that the code is not running in our environment. So please review or fix the issues like that. So they will send the code back. So then the development team will write the code again or review the code again. Then they will push. So here the main issue is time, and there is no proper communication, okay, from these people. Proper communication means there is no continuous communication or continuous integration with the dev and operation. Got it? So coming to DevOps, we fix the issue. The gap between dev and production, we will fix with the CI, continuous integration. This is the one of the feature of DevOps. So we can say there is a continuity from dev side and operation. So whatever change happen here, it will automatically fetch with the operations team, okay, using softwares. So the first key concept one that is collaboration. Breaking down the silos between development and operation team. Then the next key concept is automation, okay. Automation in the sense of automating repetitive tasks to increase efficiency and reduce errors. So that is one of the key concept of DevOps. The next uh, main concept is continuous integration and continuous delivery. So this process ensuring that our code changes are automatically tested and deployed to production. Then we can use monitoring and loggings. For example, continuously monitoring our application for performance or performance of systems to identify and fix issues proactively using monitoring and logging. automation, CICD. Monitoring and logging. Okay. So these are the key concepts, key features. Okay. Okay. So these are our features. Okay. DevOps key concepts. Then coming to why we are using DevOps. Okay. So that's there are several concepts for choosing DevOps. That is one of the main thing is speed. So the DevOps practices allows us or the organization to innovate faster by automating and streamlining process. Then reliability. So by integrating CI/CD and automated testing, DevOps ensures that the software is always in a releasable state. So we can say that I mean this feature is actually is a part of CI/CD. Okay, that is continuous integration, continuous deployment. Then scalability. DevOps practices like it helps to manage complex systems. Okay, so it will efficiently and scale them as needed. Then the most one is security. We can like incorporating security into the DevOps process. That is called DevSecOps. Okay, we integrating security within the DevOps pipeline. So in our lab, we will create DevSecOps pipeline as well. So it will ensure the security is integral part of the development process. Yes. Then coming to the life cycle. Okay, this is important thing. Life cycle. So the first life cycle is this is the most asked questions. Okay, when we facing interview, what is the life cycle of DevOps? The first one is plan. Second, code. Third one, build. Fourth one, test. Fifth one, release. Sixth one, deploy. After the deploy, we can monitor, right? Monitor. So these are the DevOps life cycles. Okay, so we need to learn these things like from plan to monitor. Okay, so coming to plan, in this phase we will define the visions. Okay, and the requirement and the system architecture. So that comes under the plan lifecycle. Then code is writing the actual code for the application. So that's cover the code.
Okay, I have a question here.
Yes.
What is the difference between release and deploy?
Release and deploy, it's a coming to release, it's a preparing the application for deployment in a production environment. Deployment means deploying the application to production.
Okay.
Release, yes, that's a like it's a preparation actually before
You can
deploying.
say pre-deployment.
Right.
Okay.
So coming to code, the second life cycle coming to code, it's writing the actual code. Then we need to build the code, right? I mean, the compiling the code and creating executable artifact using the code, okay? So that comes under the third life cycle, that is build. Then the test. It's actually running the automated tests to ensure the code is functional and stable. So that's covered under the part of 4 test. Then release. Release is actually preparation of
Sir,
application.
sorry to interrupt you. Can you please repeat because your voice was breaking?
Okay. So I think I covered the build, right?
Yes. Yes.
Yes. Yes. Coming to the 4th life cycle build. So in that process, we will compile the code and creating executable artifacts. Then coming to test, running the automated test to ensure the code is functional and stable. So that will cover under the test lifecycle. Then coming to release, we will preparing the application for deploying in production environment. So the next one is deploying the application to production. Then monitoring. We after deploying our application to production, we need to continuously.
Your voice is breaking up again. Sorry.
Yeah, it's breaking.
Okay, I will place my mobile.
So really, after release, I didn't hear anything.
Okay, right. Now it's stable, right?
Yeah, it's good now, I guess.
Okay, fine. So when coming to release, we will preparing our application, deploying to production environment. Okay. So the next one is deploy. So this is purely we deploy our application to a production environment. And coming to the monitoring, we need to ensure that our application is continuously monitoring. Okay. Like continuously monitoring our application performance and user feedback to ensure that everything is running smoothly. So that is covering the monitoring life cycle. So these are the life cycle in DevOps. So this is most asked questions.
Sir, can you repeat the code again? Code
Code
line.
part is actually it's for writing the code for the application. Because
Okay.
the requirement is we need to deploy some application, right? So these are
Yes.
the life cycles we need to follow to fulfill our process. That is means software development life cycle process. So for example, it's a WhatsApp application. Okay. So first we need to do what? We need to plan the application's feasibility, like define the vision, requirement, system architecture. Then next thing is we need to code the applications, right? So that comes under the code. So the developers will coding the application. Got it. After the code, okay, we have the lot of n numbers of code. So next thing is we need to build the code. So that's covering the compiling the code and creating executable artifact. After the build, we can test our application. So running automated test and ensure that the code is functional and stable. That's a step-by-step process when we go through the software development lifecycle. Got it. So as a DevOps engineer, we will start from build. Okay. For example, the plans, this part of actually architect. Okay. And I mean, for example, now that organization have some developers there, some operation teams there, some architects there. So all the peoples combine and they will discuss on the plan phase. So coming to code, this is purely dev teams, okay, where the developers build, I mean, write up the codes. So then next phase is build. From here, we need to work, building the application, testing, releasing, deploying, monitoring. These are all under part of DevOps job, DevOps role. Got it.
Yep.
That is the part of like life cycle. Then we need to learn some key tools that we use in DevOps engineering. Okay. So the key tools like version control. Okay. First one is version controls. So coming to version controls, we will use some tools, that is Git. Okay, that is the most common tool that we use in version control is Git. So actually Git allows us to, or the team to track the changes in code and collaborate efficiently. We will go through these Gits in a separate section, okay, in coming labs. So this is just an overview of the tools that is used in DevOps engineering. So coming to next tool, CICD, okay. These are the key tools, okay. CICD. So in coming to CICD, we use some tools, okay, like Jenkins, GitLab CICD, sorry, GitLab CI, Circle CI. There are common tools are there, okay, open source tools. So in our course, we mostly use Jenkins and for CI, okay, CI and CD, and Argo CD we use for the CD part. So the coming to CI/CD tool, that tool, why we use that tool? It's for automating the process of building, testing, and development. That means these process like building, testing, development. Oh, okay. These are the life cycles we need to automate using the help of some tools. Tools, okay. That tools is for CI and CD. So in our course, we use the tool name Jenkins. For what? For automating these process, building the application, testing application, and deploy application. Got it. So all the things we use. I mean, we automate these things, okay, using the help of Jenkins. So next tool is configuration management, okay. So coming to configuration management, we will use some tools that is called Ansible, Terraform. So we need to use these tools for managing infrastructure as a code, okay. That is a term, infrastructure as a code, IAC. So using infrastructure, okay. For example, we need to create some infrastructure like compute, database, or network, or any of infrastructure. So we, as a DevOps engineer, we didn't go through the console, or we didn't manually do the job. Okay, we need to automate the process. So we use IAC tools like Terraform or Ansible to automate the infrastructure deployment. Then the next one is containerization. Okay, so containerization, under containerization, we use the main tools like Docker, Kubernetes, Docker and Kubernetes for packaging application and managing them in a isolated environment.
Can you repeat again, sir?
Yeah, sure. Containerization. Okay. Containerization. Under the containerization, we will use the tool Docker and Kubernetes. So why we use Docker and Kubernetes? For packaging applications and managing them in an isolated environment. So for that purpose, we will use Docker and Kubernetes. Got it. So coming to next tool, monitoring and logging. For monitoring and logging, we use different tools. In our course, we will use Prometheus, Grafana, Node Exporter. So many tools are there, open source tools are there. So we will integrate these tools with our CICD pipeline or different, like we will monitoring Kubernetes or we will monitoring Jenkins server or virtual machines. So many infrastructure we can monitor using these types of tools like Prometheus, Grafana, and Node Exporter. So we can monitoring the health of application, okay, or monitoring the health of infrastructure. Then the platform, okay. Then platform, there are different cloud platforms there like AWS, Azure, GCP for deploying and managing these types of applications in cloud, okay. So in our case, we will use the cloud platform AWS. Okay. So anyone have any doubt as of now?
No, sir.
Sir, I have a question. Are we gonna get any written material as well, or it's just a recording we'll get?
Yes, records and
The
notes as well.
notes. Okay, great.
So I will showcase a workflow, okay, when coming to DevOps. So the requirement is Okay. We need to create an application, okay, and deploy that application in a production environment. So this application, for example, it's a WhatsApp. So first thing is plan phase, right? So the people that involves in the plan phase, they will architecting the infrastructure, then which language they need to use. So that's all the parts under the plan, okay? So after the plan, there is the developers, for example. 3 developers are there, okay? 3 developers. And this is dev phase. We called as dev. So the developers will write up the codes and they will run and build and run and test on their own environment. That means, for example, these 3 developers have their own laptops, okay? So they will take each modules, okay? For example, this is a WhatsApp application. So the first person will take one module, the second is another module, like that. So after that, they will integrate each modules for the entire application. So they have their own repository, okay? For example, daily they will update, taking some feature update or some code updates there. So they will write the code. Then after that, the end of the day, they will push the code to a central repository. Consider this is a central repository. This is called GitHub. GitHub is a cloud repository, okay, where we can push the code, okay, to cloud. Using GitHub, we can save the code in GitHub. So coming to GitHub, they have their own project name, that is WhatsApp. So the developers will push the code to the WhatsApp folder. Okay, consider this is a folder. That folder have the application codes, subfolders, and dependency, all the things there. So daily they will push the code, or they will update the code to their repository. Okay, GitHub repository. This is purely remote and hosted in some cloud. Okay, fully managed by GitHub. So next thing is this is dev phase. Okay, so from here we need to create a operation part. Okay, using the tools, automated tools. Okay, automating what? This application we need to, here there is a lot of codes there. Okay, so what we need? We need to build the application, right? Build, test, and deploy. So for this process, we need to automate this process using Jenkins. This is a tool, Jenkins. From here we will work, okay, like a DevOps engineer. So what we will do? We need to set up the Jenkins application. Then the next thing is we need to integrate that GitHub account with the Jenkins server. Okay, this is or the Jenkins application. So the Jenkins now integrate with that GitHub account, okay, where the developers works and push the code. So Jenkins continuously monitoring the corresponding WhatsApp application folder. Okay, so the Jenkins can read the applications that are available in the WhatsApp folder or the repository. We called as repository, okay, for the folder. So for example, Jenkins needs to build. First step is we need to build, right? So coming to Jenkins, we need to configure that required things. Okay, the configuration means here we need to configure same application and we need to build. Okay, so all the things that we need to provide inside the Jenkins configuration. All the things means what are the things we need to automate. So in this case, we need to automate what? this build process we need to automate. Then test, you need to automate. Then the deploy, that we need to automate. So all the things we need to provide inside the Jenkins. And we need to choose where the codes belongs, that we already integrated. Okay. So we created a job. Here we called as jobs, okay, Jenkins jobs. So we created the jobs and provide all the things that we need to automate, okay. So whenever we run the job, okay, run the job, the Jenkins will go through the each scenario. Like first is go to the build, test, and deploy. Before that, Jenkins will taking the entire code, okay, from the GitHub account. So the code, all the codes are in Jenkins now, and it will automatically build, test, and deploy. So the deployment, we need to choose the corresponding deployment infrastructure, okay. For example, this is our production environment.
Sir,
Yes.
sorry to interrupt. Sir, can you please tell me one more time, like how the code from Git will come to Jenkins? Like it will pull it, or like how, or will do some sort of integration or something?
Pull. Means
Okay.
Jenkins pull the code.
Okay.
Actually, not pulling, means coming to the configuration, okay, Jenkins configuration, we will provide the GitHub, okay, GitHub URL.
Oh,
Not
yeah,
GitHub,
yeah, yeah. I
that
got it.
repository URL, that application.
Okay.
So the
Okay.
Jenkins can using
We'll go
a
there and read the code and do the whatever the functions
right,
needed. Okay,
right.
got it. Okay.
So yes, the last stage is automated stage is deploy. So we need to configure the deployment environment within the Jenkins configuration. Okay. So the Jenkins will automatically deploy to the production environment. This production environment might be virtual machine or Docker or Kubernetes. That is also as per the requirement. Virtual machine or Docker or Kubernetes. So this is the simple workflow. Okay. So here we can say CI, CD. So this is continuous integration and this is continuous deployment. So for example, okay, now we build all the things and deploy to Docker. Okay. So now we will, how we can say this is CI and CD, this infrastructure. For example, now the application is running. Okay. This is version 1. So the dev team plan again, okay, we need to add some features. For example, this is a WhatsApp application. So we need to add the story feature, okay, or we need to add story feature in our existing application. So the developers, what will they do? They will taking the code from their repository and they will add the new feature and test it on their own environment. After that, they push back to the code to GitHub, right? So whenever there is no code change here, this Jenkins knows, because the Jenkins continuously monitoring that GitHub account, right? So the Jenkins know there is some new code change happen in our repository. So whenever there is new code change, the Jenkins do what? Jenkins will do the same thing again. I mean, build the code again, test the code again, and deploy the code again. So we didn't bother about that thing. And the Jenkins automatically taking the new code and here building, testing, and again deploy to that production environment. So the new features here, the users are there, okay, the end users that yes, the end users get the new update from use whenever they're using the application. So then users can getting the new features. So here we can say this is continuously integrated and continuously deployment using the tool Jenkins. Got it?
Yeah.
So coming to our labs, we will build.
One question.
Yes, please.
So the Docker and Kubernetes are not in Jenkins. That's a production environment.
Right. This is
But
infrastructure.
you do testing in the production environment, or on a Docker and Kubernetes, you would test it before you deploy it to production, right?
Test in the sense of?
Test like continuous integration, continuous testing, and so
continuous testing. Some application we use continuous testing like UAT testing or Selenium testing. So we need to include that application and integrate with the Jenkins. For example, we need to use Selenium testing. Okay, Selenium. So coming to Jenkins stages, okay, we need to include that Selenium testing, and at that time, the Jenkins setting the code for Selenium testing, then we will get a feedback from the Selenium. Then we can go with the production or the next stage. Got it?
yeah.
Any other doubt? Anyone? All are fine, right?
Yeah.
Yeah.
So coming to the prerequisites, okay, before jumping into this DevOps, we need to learn some basics, okay? So what are the things? First, we need to learn cloud.
चुप हो सकते हो?
We need to learn some cloud services. AWS cloud services, okay? So under the AWS cloud services, we need to learn networkings. This is virtual networking. So we need to learn before virtual networking, we need to learn physical networking. Then virtual machines. Before virtual machines, we need to learn physical machines. Then, yes, like operating systems. Then we need to learn Linux, including Linux commands. Okay, so we will start from like these services, like networking, virtual machines, and Linux commands. Then gradually we will jump into, after covering these parts, we will go through the tools that we use in DevOps, like Jenkins, Docker, Kubernetes. Then there are some tools are there, okay, SonarQube, Prometheus, Grafana. So we will learn each tools differently. After that, we will integrate all the tools using CICD when creating CICD. Got it? All of you.
Yes.
Yeah.
Okay. So is anyone have any doubt?
I have one question. On the left side of your screen, where a virtual networking points to. You have physical networking and then physical, what is written underneath it on the left
Here,
side.
right? This one, right?
Yeah,
Physical servers.
physical servers.
Yes.
And on top,
Yes.
it's physical networking.
The first one is, I mean, we need to learn virtual networking and virtual machine, right? But I don't know that. I mean, Pooja and Deepthi have knowledge on physical network and that physical servers. So before that, these are the prerequisites. So we need to learn from scratch. This is a scratch, and this is the advanced version. That is, now we didn't see the machines or the network, right? So all are virtual. Before that, we need. This is not. This is actually a theory part. Okay. How we creating networking. This virtual networking in on-premise. So we will cover that on-premise scenario. How to create a networking, how to create a local network in office, schools, or college, in corporate, like that. Then coming to virtual machine, we need to learn the physical machine first, right? Because that's a scratch thing here. So we need to learn how the physical servers look like, or that what is server, and all the things we will cover. Then we will jump into the virtual machines. Got it? It's just a explanation, a theory explanation why we use these things physically. Got it, Kamal?
Yes.
Okay. All are good, right? Any doubt?
Yes. No doubts.
If anyone have any doubt, then we can discuss here. Okay, no problem. Because we can't go with the doubts, right? We need to sort it out and clear. Then we can go to the coming classes. The next class, from next class, we will go through the labs most probably.
Sir, is it possible to change the timings?
Timing, your preferred time is 6, right? IST.
Yes.
All are okay with that timing? Deepthi, Amol.
It's
6 means you mean
6
at that
a.m.
time, yeah, 8:30, I think. In Canada, it will be 8:30 around PM.
Yeah, that's fine by me.
Yeah, that's fine, sir. If it is 8:30 means I will be okay.
So
Pooja,
what time you're saying? So
the time,
yeah.
IST 6 a.m.
Okay, yeah, that is good for me.
Okay, if all are okay, then I can. I'm also free. I'm available for
okay.
that. Okay,
Even
then
I'm
we
okay.
can from next class we can sit on 6 a.m. IST, right?
Yes.
All of you.
Yeah. Okay.
Yes.
Okay, that would be fine. No problem.
Okay.
Okay. Then if anyone have any doubt, otherwise we can wind up today's section.
Okay. Thank you, everybody. Have a good night and good morning if you're in India.
Yeah, thanks.
Thank
Okay.
you.
Bye. Bye all.
Bye.
Bye, sir.
Bye.
Bye.